welcome to my channel. This is Decagon Math. In today's video, I'll be solving a question on sum of geometric progression. And I'll read the question thus. The sum of the first two terms of a geometric progression is x, and the sum of the last two terms is y. If there are n terms in all, then the common ratio is, so to calculate the common ratio with the information given, right? And as I will always say that mathematics is not difficult. So when you see this type of question, all you need to do is read the question again, read it, read the question to yourself, you know, again and interpret it, right? So we start with the first statement, which is the sum of the first two terms, right? Now, when we write down geometric progression, so it looks like this. You know that the first term of a geometric progression is a, right? And then the second term is AR, right? And the third term is AR raised power 2. So now look at this. This is T1. This is second term. This is third term, right? So now what you observe is that now then when we go on, now you observe that here this is T1. Actually, this A can be written as AR raised power 0, just to show that it is also having R, which is the common ratio, right? So we observe that the power of R here is 0, the power of R here is 1. So now when this one is 1, this is 0. When this is 2, this is 1. When this is 3, this is 2. So that means for any term, we just subtract 1 from this to get the power of the half. All right. So now when we continue, definitely we can say that if we call this one, let's say we start from Tn minus 1. So for Tn minus 1, we know that it will be AR raised to the power of that will be n minus 1 minus 1. Now, I've explained before that when you observe it, 3 minus 1 will give us the power of R. So to get the power of R, we subtract 1 from the term, right? From the nth term. So this is second term. So to get the power of R here, we subtract 1 from 2 and we get 1. Here we subtract 1 from 1 to get 0. Here we subtract 1 from 3 to get 2, right? So that is the pattern. So talking about n minus 1, that means we subtract 1 from n minus 1 to get the power of R, right? All right. And then when we move on, we have that is the next one we're going to have. So the next time, to get the next time, we add 1 to this, right? Because this is 1 plus 1 2 plus 1 3. So when we talk about Tn minus 1, we add 1 to this, right? And we get n. So that means the last term, this is the nth term, the last term, right? So the last term will be AR. Don't forget to subtract 1 from this. So that is when you subtract 1, that means when we subtract 1 from this, n minus 1, then the power of R will be n minus 1, right? So we have that the nth term is AR raised power n minus 1. In fact, that is our formula for calculating the nth term of a geometric progression. We remember that the nth term of a geometric progression is equal to AR raised to the power of n minus 1, and that's what we have here. All right. So this, I can just write this as n minus 2. So you can see this will give n minus 2, right? N minus 2. All right. So that means these two here, they are the last two terms. So those ones are the last two terms, while these two here are the first two terms. So that is the information that we have in the question. See, the sum of the first two terms, right? The sum of the first two terms. In fact, I'm supposed to use a black pen. The sum of the first two terms, and we also have the sum of the last two terms. So this one is x, and while this one is y. So that means when we add this T1 plus T2 gives x, and when we add this, it gives y. So let's do that here now. So that we have that sum of the first two terms, that is T1 plus T2 is A, right, plus AR, because A raised power 0, that will give A, right? And we are told that it's equals to X. So that means that we can say, so this implies that A into bracket 1 plus R equals to X. So let's call that equation 1. And then when we add these two, that is the last two terms. When we add the last two terms, that is Tn minus 1 plus Tn equals to, that is AR raised power n minus 2 plus AR raised power n minus 1 is equals to Y. That is this, right? We can write that AR raised power n minus 2 plus AR raised power n minus 1 equals to Y. Alright? So this can be written as AR raised power n dot R raised power minus 2 plus AR raised power n dot R raised power minus 1 equals to Y. So what I've done here is so what I've done from here to here is to rewrite this one as a product. So when we have R raised power n minus 2, right? So we have R raised power of n, right, dot R raised power minus 2. We know that by the law of indices, it becomes R raised power n minus 2 again. So what I've done is just to break it down because of what I want to do. Alright. So with this now, AR raised power n is common, so we can factorize that out. We have AR raised power n into bracket R raised power minus 2 plus R raised power minus 1 equals to Y. Alright. So moving on, what can we do? So the next thing we can do is that we can write these ones like this. AR raised power n into R raised power minus 2 is the same thing as 1 over R squared plus, and this one is 1 over half, right, equals to Y. So now let me just do this one somewhere here then, so that just to save our space. So we have that 1 over R squared plus 1 over half. So when we find the LCM, that is R squared. So R squared in R squared is 1 plus R in R squared is R, and is 1, that is R. So this becomes 1 plus R over R squared. So we can write it as 1 over R squared into 1 plus R. Right? So this can become this. So from here, what you have in this bracket has been simplified to this. So we have this one to be AR raised power n dot 1 over R squared into 1 plus R. So I've just, what is here is what I'm writing here. Then you have equals to Y. So what do we do after this? Now this one is over 1, right? So this one becomes AR raised power n over R raised power 2 into 1 plus R equals to Y. Alright? So applying law of indices to this, R raised power n, R raised power 2, they have the same base, that is R. So we can apply the law of indices and write this as AR raised power n minus 2. This power minus this power, right? That is law of indices. Then we have to bracket 1 plus R equals to Y. Alright. So now let's call this equation 2. So we have our equation 1 here, and we have equation 2 here. So what we're going to do next is to divide equation 1 by equation 2. So we write that divide equation 1 by 2. So that implies that we have equation 1 over equation 2. Right? So to do that, I have to raise this side. Right, so to do that, I'm going to write, let me try to manage this side. So equation 1, that is 1 over 2. That means A into bracket 1 plus R, right, over this one here, this side, left hand side divided by left hand side, right? Here. So we have over AR raised power n minus 2 into bracket 1 plus R. Now we have equals to, that is X over y. That means right hand side over right hand side, right? The right hand side here over the right hand side here. That is x over y, right? So what we observe is that this cancel this and a cancel a. So we are left with 1 over r raised to power n minus 2. So we are left with 1 over r raised to power of n minus 2 equals to that is x over y. Then we can take the reciprocal of both sides. So taking the reciprocal of both sides, this one becomes r raised to power n minus 2 over 1 equals to y over x. So this is what I mean by taking the reciprocal. So when we take the reciprocal, denominator becomes numerator on both sides. All right, so this can just be written as this, right? So the next thing is to now we have y over x. Now this power here is what we are going to use to divide both powers. So that is 1 over n minus 2, 1 over n minus 2. So n minus 2 cancels n minus 2. So we have that r equals to y over x divided by x very well. X is to the power of 1 over n minus 2. Right? So let's check for the correct option. So that is y over x raised power n minus 2. Y over x raised power 1 over n minus 2. Sorry. So this is the correct answer. So this is the working to this question. As I said earlier, that it is not difficult. If you like what you have seen, if you like the lesson, follow me, click on the plus button to follow me on TikTok, and you can also subscribe to my YouTube channel, Match Rudiments. That's on YouTube. You can check my profile, my bio. You see the link there. Just click on it, take it to the channel, and subscribe. So thank you guys for staying through. See you again. Goodbye.